Hello everyone, this is Mr. Mohammed Hussein from Al Noor International School, your grade 10 geometry teacher. Welcome to week 9, chapter 11, lesson 5, volumes of pyramids and cones. Here are the objectives of the lesson: to find the volume of pyramid, and a cone, to write the formula to calculate the volume of a pyramid and a cone. Let us see at the key concept of the lesson. Number 1, the volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. The volume of pyramid is 1/3 the product of the area of the base and the height of the pyramid. That means if B is the base area of a pyramid and H represents the height of the pyramid, then the volume equals 1/3 of B times H. Look at these figures. The first one is an oblique pyramid whose base area is B, and the height for the oblique pyramid will be landing on the other side, which is this one. And for the right pyramid is just straight up. This is oblique because it's tilted down, and this is right pyramid because it is standing properly, and the height is at the middle. Compare the height of this one and this one. The height for this one lies on this side, but for the right pyramid it is from the vertex to the middle of the base. And here also it's right pyramid, which base is triangle, so this is triangular pyramid. Still the height lies in the middle of the triangle, so this represents the base area and this is the height. In these three cases, of course, the base area different from each other. For example, if this is rectangle, the base area will be base times height, or length times width. And here also, if it is square, you can multiply the base times height, or length times width, or if it's x times x. If it's square, all sides are the same, so x times x. Here, since it is triangle, the base area formula will be 1/2 times base of the triangle times height of the triangle from this point. The height of the triangle from this point. Concept number 2, the volume of a cone is 1/3 the product of the area of the base and the height of the cone. The volume of a cone is 1/3 the product of the area of the base and the height of the cone. Again, if B represents the base area, which is circular, and H represents the altitude, which is H, then the volume will be 1/3 times base times H. Same thing is true for the second part also. This is the base area and this is the height. The cone can be in different position. Either it's vertical or horizontal, or it can be an oblique. By this way or that way, the formula to find the volume will be 1/3 times base times height. Example number 1, find the volume of the pyramid. What is the volume in cubic feet of a square pyramid with base h 24 feet and the slant height 30 feet? So as you can observe from this figure, this is square and its edges are 24, 24, 24, 24. Then it's given that the slant height is 13. The slant height is the height which is drawn from the vertex to one side of the base figure. That means this is 13. And since this is square, half of 24 will be 12. half of 24 will be 12, and this is the height. Then you can find the heights by using Pythagorean theorem, as this green triangle shows right angle triangle with the givens 12, 13 and h. That means the volume is equals to 1/3 BH, so V equals 1/3 24 times 24, because the base area is a square, it is side times h, but we don't know h. H squared will be 13 squared minus 12 squared, which is 25. H squared equals the hypotenuse minus the leg squared. It's h squared is equals 25. Then h will be the square root of 25 is 5 feet. So you can substitute now this value in the first formula in the place of h. Then V equals 1/3 times 24 times 24 times 5, which is equals to 1/3 times 2880. This is the product of the three numbers. Finally, you will get the volume is equal to 960 feet cubed, because the volume is measured in cube. Don't forget to put cube for area squared. Example number 2, find the volume of the cone. Find the volume of the cone. A right circular cone has a height of 10 meters and a base diameter of 25 meters. What is its volume? As you can see from this figure, this circular base is a circle, so with diameter 25. If the diameter is 25, so the radius will be 12.5, 12.5, and the height is already given, it is 10. So we can use our formula. Volume is equals to 1/3 BH times or equal to 1/3 times pi times r squared times h. As the base area is circle, so the area for the circle is pi r squared. Then 1/3 times pi times 12.5 squared, because our r is 12.5, times 10. The height is 10. 1/3 is equals to 1562.5 pi. Or moreover, if you change or use pi 3.14, it would be 1635.4 meter cube. Example number 3, find the volume of an oblique cone. Find the volume of an oblique cone. What is the volume of the oblique cone at the right, which is this one? Give your answer in terms of pi and also round it to the nearest cubic foot. What can you observe from this figure? This is the circular base, where this is the center, this would be the radius, and here also radius. But you can't say this is the height, since the cone is tilted down, so the height will be this side. The height or the altitude will be here. Then this will be right angle triangle, and this is a hypotenuse with, this is 6, which is the same as this distance, which is radius, equal to radius. Then we can use our formula. V equals 1/3 times BH, or 1/3 times pi r squared times h, as the base is circular. This is the base area for the circle. Then substitute the given values here. 1/3 times pi times 6 squared times h, because we don't have h. How can you find h? You can use Pythagorean theorem from the right angle triangle. So h squared is equals to the hypotenuse squared minus 1 leg squared, that is 10 squared minus 6 squared, which is equal to 64. Take the square root of 64, the height will be 8. The height will be 8. Then substitute back this in the first formula. So 1/3 times pi times 6 squared times 8 will be simplified to 96 pi feet cubed. Or if you use the pi at 3.14, it will give you 301 feet cubed.